Good afternoon, class. Today we'll be looking at zeros of polynomials, and we're going to start off with something called synthetic division. Let's see. Synthetic division will be the first thing that we see. I'm going to. Synthetic division is a shortcut for polynomial long division. And I want you to look, I'm going to remind you of what. It's a shortcut for polynomial long division. And now that we're talking about division, we better make sure we're familiar, we're all using the same terminology. There are generally three accepted methods of expressing division. We can say the thing that's being divided is called the dividend. So we could say, using the old-fashioned notation for division, we could say dividend divided by the thing that's doing the dividing is called the divisor, is equal to, what do you call the answer of a division problem? Starts with a Q. Quotient, I agree. Another way of expressing division is the old fraction bar. We could say dividend over divisor is equal to quotient. And still another way of expressing division would be the old long division symbol. Now remember that old long division symbol? The thing that's underneath the division symbol, that's the dividend. The thing doing the dividing, that's the divisor. And the thing that goes up there on top is the quotient. And the number that's left down at the bottom, if you have a number there, that number is called the remainder. And I'm assuming y'all remember performing long division, even if it wasn't polynomial long division. This symbol, this old division symbol, they still do that in public schools, right? Divide like this. Yes, y'all, maybe in the, I don't know what grade, 4th grade, 3rd grade, when did y'all do long division? 5th grade? Okay, that's when I saw it too, but I didn't know things have changed so much over the past 50 years. I think for synthetic division, I'm going to show y'all, I have a picture of polynomial long division here. Let's see, does this look familiar to y'all? Does this look familiar? You say x times what gives you 3x cubed, and you put a 3x square. Then you go through multiplying, and then you subtract. So you have to draw the line and change the sign. Synthetic division is a shortcut for this stuff here, provided the divisor is in the form x plus or minus a number. To be able to use synthetic division, you need that divisor to be in the form variable plus or minus a number. So for synthetic division, to be able to use it, the divisor must be in the form x plus or minus a constant k. So when you look at that little example picture I had here a moment ago, this problem would be suitable. Synthetic division would be suitable for this problem because the divisor is variable, in this case minus a number. If the divisor is something like 3x squared, you can't use synthetic division. It has to be a linear factor of the form variable plus or minus a number. And to illustrate this, I think we'll just start with number 4. Okay, let me write this problem down. We have 3x to the 4th minus 18x cubed plus 16x squared minus 8x plus 15 all divided by, is that x minus 5? Yes. Okay, let me make sure I didn't miscopy this, because if I did, I'll throw my answer off a lot. Okay, to set up the tableau for synthetic division, the first thing you do is determine the k-value. The k-value, well, first look at this divisor, variable plus or minus a number. So because the divisor is in the appropriate form, we can use synthetic division. The k-value is the number that you would have to use to give you a denominator of 0. What will k equal? What number would you have to plug in for x to make that denominator 0? Positive 5. So you might want to remember the k-value is just the opposite of that number you see in the divisor. You see a negative 5, so your k-value is going to be a positive 5. And then make sure that in the dividend the terms are in descending order. You start with the largest exponent, x to the 4th. That coefficient is 3. And then you go down from there. This is the coefficient of the x to the 4th term. Maybe we'll put some column headings here. Then x cubed, x squared, x, and our constant c. The coefficient of x to the 4th is 3. The coefficient of x cubed is negative 18. For x squared, that's a positive 16. For x, the coefficient is negative 8. And our constant is a positive 15. Skip a line. To get the process started, you take whatever the leading coefficient is, you move it down below the line. So we have a 3. And now you begin. 3 times 5 is a positive 15. Negative 18 plus 15 gives us a negative 3. Negative 3, you go back and multiply by the k-value. When you bring a number down, you multiply by the k-value, and you keep repeating that until you run out of these numbers up here on top. 5 times negative 3 is negative 15. 16 minus 15 is positive 1. Multiply again. Positive 1 times 5 gives you a positive 5. What are we going to have down here? Okay, negative 8 plus 5. I agree with that. Negative 3. Negative 3 times 5 gives us a negative 15. 15 minus 5, that last number there is 0. There's no more numbers to bring down and multiply, so you're through with the process. Now stop and think. You have a 3x to the 4th, and you're trying to divide it by x. 3x to the 4th and you're dividing it by an x. Remember, the divisor is always going to be in the form just an x and then a number. So that leading term, 3x to the fourth, is being divided by x. We can cancel 1x above and below, and what does that leave us? 3x cubed. I agree. We canceled 1x above and below. We started off with 4, so now we have 3 remaining. So the variable part, this number here, is the leading coefficient of the quotient. Your variable part will start off x cubed. So we have a 3x cubed minus, you're going to decrease by 1 as you sweep across, x squared, x, and finally my constant. This number here is the remainder. So the quotient is 3x cubed minus 3x squared plus 1x, I'll just write it as x minus 3 for my final answer. Any questions there? We can say that x minus 5 divides evenly into this messy polynomial here. Divides evenly means the remainder is 0. If the remainder is 0, I'm going to write it back over here. Remainder equals 0 means the divisor divides evenly. Into the dividend. Into the dividend. So I'll be talking, for example, 4 divides evenly into 8 because 8 divided by 4 is 2, remainder is 0. Dividing evenly just means that the remainder is 0. So we come back over here. Tony, are you going to stay over there, or do you want me to type this answer in? There it is. It's 3x cubed. Get out of the exponent. We've typed exponents before, right? We're using that little superscript button. But the key shortcut that's always quicker for me is just the shift up arrow. 3x cubed minus 3x squared, get out of the exponent, plus x minus 3. Any questions there? Number 1. Oh, look at that. This one is multiple choice, isn't it? Okay, so instead of using an X, they're using a C. So, number 1, let me write the problem down. C cubed minus 7C squared plus 30C minus 22 all divided by C minus 5. Oh, this was a bad problem. Let me make sure that miscopy. Notice the divisor is just a variable plus or minus a number, so we can use synthetic division to perform that division. What will my K value be? It's another 5. You look and ask yourself, here's the divisor. When does that equal 0? At a positive 5, so the K value is a positive 5. That's why I said this is a bad problem, because it's just like number 4 in the sense that you have the same K value, but that's okay. k is equal to 5 again. At least it's not a k value of 1. And we have the coefficients for c cubed, c squared, c, and then the constant. I'll write it out since we're already using the c. I can't use c for constant like I did right there since c is the variable. Let's write out the coefficients. You start with the one with the biggest exponent. The coefficient for c cubed is 1, and then c squared, negative 7. The constant, c, positive 30, and then my constant is negative 22. So we'll skip a line. Hopefully from this first thing you see why that number, the leading coefficient of the dividend will be the leading coefficient of the quotient. You're looking at number 4. You had 3x to the fourth and you're dividing it just by x. 3 divided by 1, you're starting off with 3. That's why that number there is just carried down. That's going to be the coefficient, the leading coefficient. Then you go 1 times 5, that's a positive 5. Negative 7 plus 5 is a negative 2. Negative 2 times 5 is a negative 10. 30 minus 10 gives us a positive 20. What number am I going to have here? What number will go right here? Positive, I couldn't hear you. Positive 100, 5 times positive 20. A positive 20 is positive 100. Negative 22 plus 100 gives me a positive 78. Does c minus 5 divide evenly into this polynomial? Up here, x minus 5 divided it evenly because the remainder was 0. What's the remainder in this case? 78. So it doesn't divide in evenly. Okay, what's the variable parts for our quotient? We started with the c cubed. We divided it by c. So the leading variable part is c squared, and then c and my constant. So we could say our quotient is 1c squared minus 2c plus 20 with the remainder of 78. I think there's only one that has a remainder of 78. A, B, C, or D? Okay. Any questions there? Okay, I want you to consider the following function. It's the same dividend we have here, but I don't like those C's, okay? So I'm going to label it f of x. F of x is equal to x cubed minus 7x squared plus 30x minus 22. So it's the same as the dividend, except I changed the x's to c, the c's to x's. I want us to find, Tony, why don't you open up your calculator? I want us to find f of 5. F of 5. We know what function notation means. That's saying go to your function f, and wherever you see a variable, you're going to replace it with what? 5. So we have 5 cubed minus 7 times 5 squared plus 30 times 5 minus 22. I have a point to all of this. So that's a 125 plus, no, that would be a 125. So that a minus 175 plus 150 minus 22. What's that giving us, Tony? Look at that, 78. We plugged 5 into the dividend, and we got 78. 78 is familiar. Where do we see 78? It's the remainder. That is not a coincidence. If you plug that k value into the dividend, then you're going to get that remainder, whatever that remainder is. In this day and age, that may not be that significant. With the calculators like that, it's so easy just to plug in messy numbers with exponents and evaluate. But think back to the olden days where students weren't carrying calculators around with them. Maybe they needed to evaluate some algebraic expression at a number. Going through, suppose we were trying to plug in 15 instead of 5. If we were trying to plug in 15 cubed, you'd have to do that by hand. 15 squared, do that by hand, then multiply through by the 7. Just think about how messy it would have been to evaluate these things if you didn't have a calculator. But look at synthetic division. Is there any exponentiation going on here? With synthetic division, the only thing you're doing, you're multiplying and you're adding and subtracting. That's it. So if you look through old-fashioned, algebra books from a long time ago, when people needed to evaluate functions at constants, it was common practice. Use synthetic division, and that last number was the value of the function. As I said, in this day and age, it's not really that significant with the popularity of calculators.
The state of Texas says it is now.
Yeah, the state of Texas said, but you got to understand, the people sitting around deciding on what we're teaching in these math courses, some of them may not have, some of those state representatives may have never taken a college level algebra course, okay? You don't have to have a college degree to run for the state legislature. I can see the people sitting around a table looking through an algebra book, and they see something called the remainder theorem. And they know what a remainder is. That's the thing that's left over when you're dividing. And I can see the people, yes, students need to know how to divide. So include the remainder theorem. Well, I doubt they knew the details of what the remainder theorem actually said. The remainder theorem says, okay, so, okay, if you evaluate a polynomial function at the number k, you're going to get the number that's the remainder if you divide it by x minus k.
No, Tim.
It is not a coincidence that when you're using, let's go back to that number 4 that we did a moment ago. Suppose I wanted to plug 5 into this thing right here. Suppose I needed to plug 5 into that dividend. What's it going to give me? 0. The remainder is 0. So I know if I plug in 5 here, 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 and here, and simplify, I'm going to get 0.
Can y'all imagine doing that by hand? 5 to the 4th. Well, that would be, 625?
Times 3.
Times 3, 1875. Okay.
I can assure you that this synthetic division, notice we didn't have any taking 5 to the 4th power. It's only multiplication and addition, subtraction. Much less messy mathematical calculations using synthetic division than trying to plug that number in by hand. So.
And I started to interrupt you a moment. Did you review what a polynomial is? We talk about a polynomial. It's just a
sum or difference of powers of x, integer, non-negative integer powers of x, I guess counting numbers, the things that have x square, x cube, x to a positive integer, a sum or difference.
Yeah, no square roots in it, stuff like that.
Looking at number 5.
Okay. Let's go to number 5.
They give us a polynomial function. The biggest exponent on a polynomial is called the degree. So this is a third degree polynomial function. Let me make sure I didn't miscopy something. And they say use the remainder theorem and synthetic division to find f of k for the given value of k. And the k value is what? -5. So they want us to find f of -5. Find f of -5. If you have your calculator sitting there, Tony, if you have your calculator sitting there, then you could just plug in -5 wherever there's an x and simplify, but they want us to do this using synthetic division. Our k value, they gave us the k value of -5. The largest exponent is x cubed. I'll put my little column headings. X cubed, x squared, x, and my constant. Call out the numbers I'm writing across. Here, -2. Here, -12. Here, sign, -11, and finding my constant, -1. And to get the process started, you bring down that leading coefficient. So you bring down the -2. -2 times -5 gives me a positive 10. -12 plus 10 gives me another -2. What am I going to do with this second -2? Multiply by -5. -5 times -2 gives us a positive 10. What number will we have here? -11 plus 10. I agree with -1. Here, positive 5. You take the -1 times the -5 to give you a positive 5. And then -1 plus 5 gives me a... Wait a minute. I think it's a positive 4. -1 plus 5 gives me a positive 4. One of these numbers is our answer. Which one? F of -5 is equal to what number? If we plugged in -5 all the way across, what would be the value? F of -5 is equal to... I'll give you a hint. It's called the remainder theorem. It's called the remainder theorem. 4. Okay. The remainder is the value you get when you plug that k value into the function.
I think they were looking at what I was punching into the calculator. That's why they weren't asking or answering. Let's see. It better be 4, is it? Yeah.
Mm-hmm. And I mean, if you were doing this without a calculator, and you need to know what does that equal if you plug in a 12, If you're doing it without a calculator, I can assure you synthetic division is quicker. Nowadays, you don't see these little synthetic algorithms appear, synthetic division algorithms appearing the way they did back in algebra books that were written in the 30s and 40s and 50s, where everything was done by hand. But any questions there?
Mm-hmm. Oh, what was it? 4?
4. Oh.
What's wrong?
Go get my car. I put it on the desk up there. Okay. Any questions? But I can see how remainder theorem got mentioned, and it's stated when the state began their student learning outcome project over a decade ago. We all wondered, how did this thing get in there? Well, I can see a bunch of good old boys sitting back
Now,
there.
Tim, what if they're watching and listening to you?
Yeah, I'm sure. Okay, but I can see that. I can see people just saw the word remainder and they thought, oh yeah, they need to divide. Students need to know how to divide and find remainders. They didn't realize that it was actually a algebraic theorem.
Which is a
Also, here's something else. There's something called the fundamental theorem of algebra. The fundamental theorem of algebra. That must be pretty important, don't you think? Was that listed by name? Did they say we got to teach that? No. They mentioned the remainder theorem, but something called the fundamental theorem of algebra says that they didn't even mention it. They didn't mention it by name at all.
Let's keep going.
Okay. Some definitions.
Oh, wait. I got to show you a page.
The number k is a zero,
That's the name of this assignment.
or in parentheses, they used to be called roots, or root of the polynomial function p of x, means that if you take that k value and plug it into the function, you're going to get 0.
I was going to see if they guess.
We're defining 0 or root. Even back when we were in school, these things were called roots. But I guess it was in the 90s where all the textbooks started switching over to the terminology a 0. A 0 of a polynomial means you can plug that number in and it gives you the value 0. Is negative 5 a 0? Look at this number 5. Would negative 5 be classified as a 0? If you plug in negative 5, do you get 0? No, you get a 4.
Let's look at all the
Let's
K's
see.
you've done.
What about this one here? Would positive 5 be classified as a 0? Yes, because if you plug in 5, you get 0. What about this one here, number 1? Is 5 a 0 for number 1? No, because you plug 5 in, you're getting 78. You're not getting 0. A 0 of a polynomial function is a number that you can plug into the function to make it equal 0. And that fundamental theorem of algebra that we were talking about, it says it gives you a limit to the number of zeros a polynomial can have. There can be no more zeros than the biggest exponent. This is what, 3? So there could be 3 different numbers you could plug in to make that thing equal 0. That's it.
But there can't be 4.
There can't be 4 numbers. Think about all the quadratic equations we've solved here in this class. What exponent has to appear when you're if it's quadratic? X squared. For most of the quadratic equations we solved, how many solutions did we get? When we were solving those quadratic equations, we were finding zeros would get 2 solutions.
That's the fundamental theorem of...
That's the fundamental theorem of algebra. The number of zeros cannot exceed the largest exponent. So if you were going to find the zeros, if you were going to set this thing equal to 0 and solve, you would expect 3 solutions, maybe only 2, but you can't have more than 3. Any questions there? There's something called the factor theorem. The factor theorem says that if you know a 0, then you can determine the corresponding factor. It says, let's see, I don't know if I want to write it like that. Is there a way for me to say it in fewer words? If k is a 0, then I'll say it like this. K is a 0. Now, k is a 0 of p of x if and only if x minus k is a factor.
Explain that it reads 2 ways.
That if and only if is important because it reads 2 ways. If you see an if and only if statement, it can also be read as if x minus k is a factor, k is a 0, so it goes both ways. K is a 0 means x minus k is a factor, x minus k is a factor means k is a 0. So let's look back up here. Let's find a 0. Here, on number 4. Don't bother writing this down. So k is a 0. The remainder is 0. So 5 is a 0. 5 is a 0. That means if we were going to factor that big messy stuff on top, one of the factors would have to be x, and it's the opposite of the number you see. You see a positive 5, so x minus 5 is a factor. So if you know a 0, you can determine a factor. If you know a factor, you can go backwards and determine a 0. Any questions on my logic there? Let's see. How about number 6? Oh, well, actually, maybe I should remind y'all of the division algorithm. I need to remind y'all of the division algorithm.
And this is something they know. They might not be able to state it.
They may not be able to state it algebraically, but they know this.
Like 6
Okay.
divided by 2 is 3.
Dividend over divisor. The dividend divided by the divisor equals the quotient.
Like 6 divided by 2 is 3.
What did y'all learn first? When y'all were going to school, what did y'all learn first? Division or multiplication? Multiplication, because division is defined in terms of multiplication. 6 divided by 2 is 3. Why? Because the quotient, 3, times the divisor, 2, has to give you what? 6, the dividend. Why does 6 divided by 2 equal 3? Because 3 times 2 has to give us 6. So I'll say, that means, here's the division algorithm. Dividend divided by quotient, divisor equals quotient means quotient times the divisor equals the dividend. Here I'm just writing it out in words, what we just said here. Quotient times divisor gives you the dividend. Any questions so far? Our goal at this point is to take things like number 5. Do y'all agree? We haven't factored anything. The stuff we've factored has had x squares. It's been quadratic. We haven't factored any cubics, have we? We haven't factored anything with higher exponents than just a 2. Our goal now is to factor higher order polynomials. It's to get a process that we can use to factor higher order polynomials. Really, I should say higher degree, but
when you're factoring a quadratic expression, how many sets of parentheses do you have?
2.
2.
When you're factoring a cubic, how many sets of parentheses do you
guess we're going to have?
3. That's right. Suppose we tried to factor this thing over here. If it were factorable, the largest exponent is a 4. How many sets of parentheses do you think we would need to factor that 4th degree polynomial? If it were factorable, it would be 4. So let's look at number 6.
So I think we're about to start factoring x cubed stuff, and our answer is going to be 3 sets of parentheses.
So this is number 6. Now you're going to have to remember how to factor trinomials, that trial and error method. All this is going to do is going to break down the polynomial until you get a quadratic expression that you can factor by trial and error or reverse FOIL, whatever you want to do, okay? I think I'll say the goal, our general process, before I even write the problem down. Our general process will be to use synthetic division and the division algorithm to factor polynomials with x cubes, x to the 4th, what have you. I'll say higher order polynomials, but I haven't mentioned, I'm going to make a note, higher order polynomials. Those are things with x cubes, x to the 4th, what have you. X cubes, x to the 4th, and so on. We know how to factor stuff that has x squares. We know how to factor quadratics, but we're going to use synthetic division and the division algorithm, and we're going to break it down to something that's quadratic.
Should you make a note, if there's an x to factor a cubic, there will be 3 sets of parentheses.
Cubic, x cube, there'll be 3 sets of parentheses.
When it's factored.
If it's factorable, whereas let's say it had an x to the 4th, you would expect 4 sets of parentheses in the factorization. And so forth.
And
so we're ready to look at number 6.
Show them the process.
Number 6. We want to factor f of x into linear factors. That means we can't just leave it with an x square. Linear can only have an x term, okay? So if we're going to factor this thing into linear factors, we're going to expect to have 3 sets of parentheses at the end. With no exponents, we have f of x equals, we're trying to factor 3x cubed plus 2x squared minus 32x and plus 32. And they tell us k equals 2 is a 0.
So they're giving you one little piece of information. They're telling you a 0.
If k equals 2 is a 0, if k equals 2 is a 0, what's the corresponding factor? I know one of the factors of this thing. There's going to be 3 sets of parentheses. I know one of them. It goes back to that factor theorem. If k is a 0, x minus k is a factor. So if 2 is a 0, that means x minus 2 is a factor. That's going to be one of the 3 sets of parentheses. We have to type that in.
Now.
Okay.
No, there's going to be 3 sets of parentheses. X minus 2, x minus k.
Whatever that k value is, the corresponding factor is variable, and then change the sign on k. The k value is a plus 2, point at the parentheses. You wind up with a minus 2. Because if you think about it, if you plug 2 into x minus 2, it has to give you 0. They told us that k equals 2 is a 0, so whatever the factor is, if you plug 2 in there, you better get 0, and we do. Let's use synthetic division. So we have our k equals 2. We have it start with the biggest exponent, x cubed, x squared, x, and then my constant. The coefficients for x cubed, that's a positive 3. For x squared, that's a positive 2. What are we going to have for x? Negative 32. What's my constant? Positive 32. Skip a line.
Tim, right here. This last number, y'all know what this last number is going to be here.
What does this last number right down here have to be? Keep in mind, k equals 2 is a 0. That means if you plug in 2, it's going to equal 0. So what does this remainder have to be? 0. We know that if you plug 2 in, they told us, if you plug 2 in, it's going to give you 0. So that last number there had better be a 0. If it isn't, we're doing something wrong. So we start by bringing down the 3. 3 times positive 2 gives me a positive 6. 2 plus 6 gives me a positive 8. 8 times 2 gives me a positive 16. What's negative 32 plus 16? Negative 16 times 2, what am I about to get right here? Negative 16 times 2 gives me a negative 32, and sure enough, 32 minus 32 gives me a 0. What's the variable part here? X squared, and then x. So think about what we've done now. We know here's the quotient. The dividend divided by the divisor gives me the quotient. Dividend divided by divisor gives you a quotient. That's why I wrote out this division algorithm. The quotient times the divisor has to give you the dividend. So according to the division algorithm, f of x, that messy polynomial, it has to be x minus 2. That's the divisor, x minus 2, times the quotient, 3x squared plus 8x minus 16. Quotient times divisor gives you dividend. We already knew that first factor, because 2 is a 0, that means x minus 2 is a factor. Notice that's linear. This isn't linear. It has an x squared. We have to keep factoring. But at this point, the new stuff is over. It's just a matter of factoring a trinomial.
What I was about to say was there's going to be 3 sets of parentheses, Here's one set. How do we get the other two? And you told them. Factor it.
Factor the trinomial. 3x squared. Well, there's only one possibility. 1x times 3x, right? What about the signs? I'm looking at that last sign. What does that tell me about the signs inside these parentheses? That x minus 2 is irrelevant at this point. We're not using that. We're just trying to factor the quadratic expression. Last sign's a minus, which means what sort of signs will I have inside here? A plus and a minus. Okay, I'll just make a little note of that. Plus and a minus. What times what will give us 16? Well, we have 1 times 16, 2 times 8. Anything else? 4 times 4. This is not a simple trinomial. We can't just look and tell what the pair needs to be, okay? But what do you want to try? Choose something. Which one do you want to try?
4 and 4.
4. If you're uncertain, if you really have no idea which one's going to work, try the pair that's closest together. So try 4 and 4. I think we're going to get lucky here. I think we're going to get lucky. Look at the outer and the inner. The outer product, that's a 4x. The inner product is a 12x. We need a positive 8. Can we get that? Yeah, if we have a positive 12 and a negative 4, that'll give us that positive 8x. So where do we need? What signs do we need in order to get a positive 12x and a negative 4x? What will I put right here? Positive and a negative. We have just now factored a third degree polynomial equation. Polynomial. X minus 2 is one of the factors. The other factor is x plus 4 times 3x minus 4. If you have time this week, what you might want to do, FOIL out x minus 2 times x plus 4. Once you FOIL that out, distribute through the 3x over it. Then distribute the negative 4 over it. You know what you'll get once you've combined all your like terms? If you multiply these three things together, what are you going to get?
I will hope they're just not saying anything.
Oh, I know. What are we trying to factor? The 3x cubed minus 2x squared, plus 2x squared minus 32x plus 32. If you FOILed all this stuff out and combined like terms, you would get back that function f of x. Y'all are quiet. This is significant. This is some of the most...
stopped doing this back in 1992. I was 93.
That is the answer.
That's the answer. We have just now factored a third degree polynomial into 3 linear factors. Before today, all we had was trial and error. Well, we could trial and error with the trinomial to get that done, but trying to come up with 3 separate sets of parentheses by trial and error would be next to impossible. So 3x minus 4. The order in which you type those parentheses doesn't matter. Just like when you were factoring a trinomial. If you put 3x minus 4 first, that's fine. It's the stuff inside the parentheses that are important.
My habit is to always put the one that goes with the K first, just because you found it first.
Okay. We've done something else, whether you realize it or not. If I wanted to know what numbers can I plug in for x to make that original function equal 0, the fundamental theorem of algebra says you can't have more than 3 solutions. I think we've got them. If you set, don't write this down, but if you set that equal to 0, a product equals 0, when one or more of the factors is 0. So if you were trying to set that equal to 0, what 3 solutions would you get? When is x minus 2 equal to 0? What would x have to be? There it is. It's the one they gave us, that positive 2. When is x plus 4 equal to 0? At negative 4, so we found the second. Here are the zeros. I'm going to write the zeros in green.
You're not asked to do that?
You're not asked to do that, but we can find them now. There's 2. You plug in 2 up here, you're going to get 0. What did you say here? Negative 4. What about 3x minus 4 equals 0? You'd have to move the 4 over and then do what? 4 over 3. Divide by 3. So here are the 3 zeros. These are the only numbers you could plug into that messy function and get 0. Could I plug in 50,000 and get 0? No. The only 3 numbers that I can use that I can plug in to give me 0 are 2, negative 4, and positive 4/3.
We better do another.
We better do another one. There's a pattern here. Use synthetic division.
No, show them the pattern.
You use synthetic division, it gives you a quadratic. You then factor the quadratic the way we've been doing it since the second week of the semester. The third factor is variable, and then the opposite of the k-value.
And if you're wondering, how do we get these k-values? It's actually pretty darn easy.
We have a big drawback to this, though. There's a big drawback to this factoring method. You've got to know a 0. You have to start off knowing a number that you can plug in to give you 0. Look at number, where's my notes? 7. Look at number 7.
Same thing.
Same instructions. We want to factor this polynomial in linear factors.
It doesn't say k equals. It just says negative 7.
4x cubed plus 23x squared and a minus 34x plus 7 and okay, let me make sure that I copy that. 4x cubed plus 23x minus x squared. Okay, given that negative 7 is a 0. Negative 7 is a 0.
It's sort of different from number 6 in that number 6 actually says k equals.
Well, I don't know that that's such a big deal, Tony.
I guess it is. But what's the k here?
The negative 7. The k value is negative 7. And we're going to factor this thing. Here I am down at the bottom of my page. I know one of the factors already. What's the factor associated with that 0? It's going to be x plus 7. There's one of the factors. Since this is a cubic, there'll be 2 more factors. To find those other factors, you have to use synthetic division. K is negative 7. My 0 is negative 7. No, it's a...
Blurry? Let me refocus. To me, it seems blurry all of a sudden.
Well, everything's blurry to me with these glasses.
That's
my other pair.
It was?
The pair I always wear just broke out of the blue. I heard a little pop and they're broken too. Very annoying. Okay, I'm going to let y'all call out these numbers up here because my voice is getting tired. Here, 4, 23, negative 34, and positive 7. We skip a line. What do I do first? Oh, what do I do next? Bring down the 4 times negative 7 gives us a negative 28. 23 minus 28, what have I got here? Negative 5 times negative 7 gives me a positive 35. What have I got here? A positive 1 times negative 7 gives me, and look at what we're about to get here. Is that surprising? No, we knew we had to get 0 because we were told negative 7 is a 0. Negative 7's a 0. That means if you plug negative 7 in up here, you get 0. The remainder has to be 0, so that's not surprising. What's the variable part of the quotient? Here, beside 4x squared, and then an x. That's the thing we need to factor now. Now we need to factor 4x squared minus 5x plus 1.
And that's going to give us these two.
Okay. So it's quadratic, so we know we draw our two sets of parentheses. 4x squared. Well, it could be a 1x times a 4x, or for 4x squared, we could have 1x times a 4x, or 2 times 2, 2x times 2x. For 1, hey, at least 1, that's going to be pretty painless. What times what will give us 1? 1 times 1, that's it. Oh, we have something else nice. What do we know about the signs inside the parentheses? Is it like that previous one where we had 1 plus and 1 minus? Okay, that last sign's a plus, so you have two of the first signs, negative and negative. And we know this number here has to be, here and here we have to have 1 and 1. So we're going to use 2x and 2x or 1x and 4x. If we use 2 and 2, are we going to get back a 5? I think we're going to have to use a 1x and 4x. And you can check that. What's the outer product? Negative. Okay. What's the inner product? Negative 4x minus 1x gives us a negative 5x. Is that what we needed? Yes, it is. Here are the other two factors. X minus 1 times 4x minus 1. If you went home and FOILed out two of those, then distributed the 4x over it, distributed the negative 1 over that, combined like terms, you would eventually get back what? If you multiply all that out, what would you get back? Okay, the f of x, 4x cubed plus 23x squared minus 34x plus 7.
So how do we factor into linear factors? You do synthetic division, and then
you still have to remember how to factor a quadratic. You still have to remember that trial and error factoring. All this does is break down a higher order polynomial until you get something that you can factor by trial and error. That's what this technique does. Any questions there?
Have I already punched it in?
No.
Oh, no, I haven't. So I always put the k one first. I don't have to, but I'm going to. X plus 7. And what is that?
X minus 1.
X minus 1. Why are you putting that there?
I'm going to let you start taking it over top.
I had mine right here. Let me turn it on.
Okay, I'm turning mine on.
Oh my goodness.
What are you
heck
typing?
am I doing there?
I don't know.
Gee, I don't know if I should be talking if that's what I'm going to be typing.
Okay, I'll take over now as we switch. I don't know what he was typing there.
I don't know
That's
what I
an
did.
X. Now realize the order doesn't matter. You could write 4x minus 1 next as long as you have 4x minus 1. As long as you have the exact same thing inside the parentheses, the order does not matter. Oh, once again, they didn't ask us to find the zeros, but once you have it factored, it's not difficult to find those zeros.
Here. Are you showing?
Mm-hmm.
The first, that's a O. Oh, okay, the first set of parentheses, what makes that 0? Well, a -7. What about the second set of parentheses? What would make this one 0? X minus 1 equals 0. Not hard.
+1, and
What about this one here? You'd have to move the 1 over.
okay.
1/4? Okay.
So once you get these things factored, you could then find the zeros if you needed to, and it wouldn't be difficult. Just set each factor equal to 0. Any questions there?
Hopefully you're getting the hang of this. Synthetic division, factor the quotient. The first factor that I always write first comes directly from the 0 that's given. How X change the sign on the 0. Let's do number 8. It's another one just like it. Okay, number 8, f of x equals 4x to the third minus 5x squared
Minus 23x plus 6.
And what do we
They
told
tell
us
us that
is 0?
-2 is a 0.
-2 is a 0. Okay. Well, I wonder what would happen if we remove this green thing here.
I don't know what purpose it serves.
Okay. Well, let's get started with our synthetic division.
Down towards the bottom, write it out. F of x equals. Okay, the first factor, the one that comes from the -2, it's variable, and then the opposite sign, so x plus 2. There's the first factor.
Okay, so we have 3 more that we're going to need. I mean, 2 more sets of parentheses that we'll need. Okay, so let's set up the synthetic division. Oh, I forgot to do my labels. Column headings. X cubed, X squared, X constant. So 4x to the third minus 5x squared minus 23x plus 6 4 -5. Okay, to get started, what do I do?
What do we do to get started? Okay, bring down that leading coefficient.
Back in the olden days, I used to do this. And I remember the time that the class asked me. They were scared to ask me, but finally someone worked up the courage to ask, what is that?
Now, I don't think I like that.
And I stopped doing it at that point. Can y'all tell what it is? It's supposed to have been an arrow showing that I'm moving this 4 down. Well, We'll forget about that now. Okay, so 4 times negative 2, negative 8, negative 5, plus a negative 8 is a negative 13. Negative 13 times negative 2 is a positive 26. Negative 3 plus 26, is that going to be a positive 3?
Negative 23 plus 26. You said negative 3 plus 26.
Oh, I did? Oh, okay. Negative 23 plus 26 is a positive 3.
What are we going to have here? No.
Well, he's getting ahead of it.
You're getting
we
ahead.
know it's got to be 0. This is going to be negative 6 right there. Now let's put in the variables. It's x squared and an x. So what we have to do now to find the other two factors is to factor 4x squared minus 13x plus 13.
Plus 3.
Oh my goodness, it is a plus 3. Maybe I better put my glasses back on. Okay. Oh, that looks really bad.
An improvement in his vision.
It's been going on for
rare,
years.
But it's been going on for several years. His vision's getting better.
Yeah. I get new glasses weaker, and that's what's happened now. Okay, draw 2 sets of parentheses. Let's see. I'll do the signs first. The last sign is a plus. So what are we going to have in here? Minus and minus?
3 is easy.
Yeah, for 3.
There's only one possibility.
1 times 3. Let's go ahead and fill that in. 1 times 3. Now, what about 4? Well, I think we had that a moment ago. It's either 2 times 2 or 1 times 4. I'll play around. Which one do you think how we're going to do it to make it work out and get that negative 13x in the middle? I am thinking it's not going to be 2 and 2.
It's going to have to be 1 and 4. Remember my little trick. That's 13 is 1 away from the product. 4 times 3 is 12. If that number is 1 away, then try using 1 in the number. More times than not, that's the one that you use. Does that give us back a minus 13x? Check the outer and the inner. Does that give us a minus 13x?
We would have a minus 12x for the outer.
What's the inner product? Negative 1x. Negative 1 minus 12 gives us... Is that what we needed? Yeah, so that's what we needed.
We have a 4x minus 1 and an x minus 3. So there's our 3 sets of parentheses. And as Tim suggested, over the next few days when you have extra time, if you want to FOIL all of that out, well, you start by foiling, then you have to distribute the x and distribute the minus 3. What will you get as your answer if you multiply all of this out? F of x. Okay, 4x to the third minus 5x squared minus 23x plus 6.
We know one of the zeros automatically is negative 2.
Oh, yeah.
How many zeros do we expect to have? It's a third degree polynomial. So how many zeros do we expect? 3. We already know 1. Can you tell me the other 2?
How would we solve this for 0?
Positive 1/4, I agree.
You'll see how we're getting that 1/4? You're imagining solving 4x minus 1 equals 0. Move the 1 over. divide by 4. When I say imagine, I mean you're doing it in your head, or else you're
What about
writing
this
it out.
one?
This one.
Positive 3.
Mm-hmm.
This is really a big deal. Y'all
Yeah.
don't seem to be impressed with this.
But they're not impressed with anything.
Oh, yeah, they are.
Oh, okay.
I'm impressed with Zelda's artwork.
Yeah. Not the mathematics. Tim. Okay. Oh gosh.
Any questions?
The natural question is what? It's okay. Let me say this. It's pretty easy to factor when you're given a 0. Just do the synthetic division and factor the quotient. But what's the natural question?
Suppose they didn't give you a 0.
How the heck are they finding these zeros?
There are infinitely many numbers that you could plug in for x on number 8. Infinitely many numbers, but you have to, if you're going to factor that, you have to know a 0.
One of these
So
zeros.
how do you find a 0? How can you come up with a 0? There's something called the rational zeros theorem. What it does is it gives you a finite list, usually about 20 numbers, that could possibly be zeros. So if they didn't give you a 0, you'd use the rational zeros theorem and come up with a list of about 20 possible zeros, and then it's up to you. Find out one of those that's a 0. Just go through the list. If I plug this in, does it give me 0? If so, great, use synthetic division. If not, go on to the next one. But here's what the rational zeros theorem says. It's going to give us a finite list of numbers that could possibly be zeros.
If we have a polynomial like this, we're going to call the coefficient on the first term, the one with the biggest exponent. I'm just giving you some terminology. That's going to be called the leading because it's in front, it's the first one, coefficient. And this last number, we already know that. It's the constant. So the new terminology is this leading coefficient.
Well, we've been using that. At least I was using it. The first number, but
Oh, I thought I heard you say the phrase leading coefficient.
I'm sure it said the leading coefficient.
Oh, okay. Like here, the leading coefficient on number 6, it would be a 3. Here, by rational, I mean fractions. It's any number you could write as a fraction. Possible, rational, zeros are in the form, and it's going to be a big old messy fraction, plus minus on the top number is going to be a factor of the constant term. And the bottom number is a factor of the leading coefficient.
You should go back to that one that we just did and apply the
That's what I'm gonna
rational
do.
zeros theorem to show that.
Factor of the constant term over factor of the leading coefficient. Here's an example.
Number 4 that we were just doing.
Find the possible rational zeros. That wasn't number 4, that was number 8.
Number 8.
Aw.
4x cubed.
Okay, it's f of x equals 4 x to the third, or x cubed,
I don't know what that is.
Oh. Minus 5x squared. So I'm just taking the problem that we just finished
Minus
doing.
23x plus 6.
And in a moment, once we move to number 9, we'll have problems like this. where it says find the possible rational zeros.
The first thing you should do, find the factors of the constant term.
I'm using constant first because that's the top.
That's the top. That goes on top.
And I guess I should have made a note. 6. What are the factors of the number 6? Well, what numbers multiply together to give 6? There's 1 times 6, and what else? I'm just listing out all the numbers that divide evenly into 6, 2, and 3. There.
You say, well, -1 times -6 gives you a positive 6. You don't have to worry about the sign changes. That plus minus in front of the fraction will take care of all the sign changes. So all you're doing is writing out the positive factors.
Now let's look at the factors of the leading coefficient. I'm just going to say LC for leading coefficient. And that leading coefficient was what number? 4? Okay. Tell me every number that divides evenly into 4. I'll give you a hint. There's not a lot. 1 and 4, and what else? Yeah, 2 times 2. I'll just list it once. 1, 2, and 4 are the only numbers that divide evenly into that leading coefficient 4. Now we're going to make some fractions in this form. You write down plus minus, and you're going to take each one of these numbers and put it over each one of these numbers. Watch how I'm moving my hands, because just hearing what I'm saying is worthless. I'm taking each one of these numbers, and I'm going to put it over each one of the factors of the leading coefficient. I'll take 1, put it over 1, over 2, and over 4. Then I'll take 2, put it over 1, over 2, over 4. Now go on until I've exhausted the list. 3 over 1, 3 over 2, 3 over 4. 6 over 1, 6 over 2, 6 over 4. So I'm taking the 1. Purple 1. So it's going to be 1 over 1. On this one, I'm going to try to stick with the colors. Oops, that's a plus minus right there. I made the minus too big. I got carried away because of my fraction bar. So we have 1 over 1. Purple 1 over blue, over red 2. Comma, plus minus. Purple 1 over red 4. I guess the 1 over 1, I'll rewrite that as 1 in a moment. Okay, I'll reduce the fractions in a moment. Now we go on. 2 over 1, 2 over 2, 2 over 4. Let's see. 2 over 1. 2 over 2, if you're really sharp with this, you could probably just not bother writing that. I'm going to write it down this first time, but notice 2 over 2, haven't we already basically listed that number? 2 over 2 would be the same as 1 over 1. And then our third number, gone. 2 over 1, 2 over 2, 2 over 4. Have I already listed 2 over 4? I think I have. 2 over 4 reduces to what? A half. Okay. So let me see. Where am I at this point? I've done 1 over, 2 over. I think I'm ready to do 3 over now. So we have Purple 3 over red 1. Purple 3 over red 2. Purple 3 over red 4. I'm seriously regretting doing this colored stuff at this point. Okay? But I figure I got to continue it. So there was the 3 over 1, 3 over 2, 3 over 4. And finally, what are we up to? We're at purple 6 over red 1. Purple 6 over red 2. Purple 6 over red 4. And now we got to reduce all of this. Okay? After this one, I'll stop. Like if it's 1 over 1, I won't write that. I'll just write what? What do you think I'll write instead of 1 over 1? Yeah, plus minus 1. That was this one. Then plus minus a half. I'm going through reducing any fractions that need reducing. And 1/4. So y'all caught up. 1 over 1 is 1. 1/2. 1/4. How am I going to write the 2 over 1? I'm not going to write 2 over 1. What am I going to write? 2. Now 2 over 2, have I already listed that one? Yeah. 2 over 2 is 1. Oh. What about 2 over 4? Have I reduced that? Have I already listed it? 2/4 is the same as a half. Okay. So I'm up to this one. The 3 over 1 is just 3. 3 over 2, I haven't already listed that. And let's see, 3 over 2. 3 over 4, I haven't listed that one already. Are y'all caught up with me? So we now have these last 3 to do here. 6 over 1, how am I going to write that? Just a 6. Oh, 6 over 2, have I listed that one? 6 over 2 is 3, so I've already listed it. What about the last one? 6 over 4, how would that reduce? 3 over 2? Okay. So the 6 over 4, I've already listed as 3 over 2. So at this point, out of all the billions and billions of numbers in the universe, here's the 2, 4, 6, 8, 10, 12, 14, 16. Those are the only 16 numbers that could give us a 0. Now, what are the 16? We know the 16 numbers that will give you 0. Here they are. We know the 3 numbers that actually work. These 3 numbers had better be listed over here. Are they? -2, yeah. Positive 1/4, is positive 1/4 listed? Yeah. And what's the last number? 3, positive 3, it's the last 0. Is it listed? Yeah. So what does this do? It gives us the possible numbers. If we had wanted to be really, oh, Tim, what's happened? Oh, okay. If we wanted to be really, really mean to y'all, then we wouldn't have assigned the ones where they gave you the 0. We would have done the ones where they didn't give you the 0. And the first thing you had to do was find the zeros. But what I want to do is just make sure you know the process. If there's ever a time where you're having to find zeros of polynomials and they don't, or you need to factor a 3rd degree polynomial and they don't tell you what a 0 is, then you can go ahead and find the possible and then start plugging them in or doing synthetic division until you find the ones that give you 0. Let's actually do one of the problems
I'll
from the
take over
homework?
now, okay?
Oh.
I have a good way of summarizing those terms. I can write them out quicker. I think it's what you were about to start doing, but still. So this
Okay.
is number 9. Okay. This is number 9. Oh, that's
wait.
number 8. Oh, you never typed in the answer to number
We
8.
didn't do number 8. You told me to.
Yes,
oh, wait,
we
yes,
did.
we did. Oh, you're right. What was this?
X plus 2
Oh, wow. I wonder
times
if it's gonna
4x
take
minus
it.
1.
Or is it in a set?
4x minus 1 times x minus 3.
X minus 3. Okay, so we got number 8 right.
Okay, let's look at number 9.
And it's going to be like what we were
One
just
thing
doing.
that's good is they're not making you type out all the possible rational zeros. They're giving it to you as multiple choice. Here goes. Okay. We want to find the possible rational zeros of, and I'm going to abbreviate possible rational zeros, PRZ, of P of X equals 2x cubed plus 9x squared plus 11x and a minus 8. Oh, there it is.
So you put the only two important numbers, green and red. Okay,
Right.
So
But there's something else I want to point out. I wanted to know the possible rational zeros of this problem here. Suppose I change it. Suppose instead of a minus 5, that's a minus 15x. And suppose instead of 23, that's a minus 123. Have I changed the possible rational zeros? Would these possible, for this new function, would I have to do this all over again? Do I use those middle terms when determining the possible rational zeros? No. The only ones I use are the leading coefficient and the constant. So those middle terms don't really matter, okay? But here we go. So let's write out the factors of 2. No. First of all, it's the constant. So we're going to write out the factors. And I'm not writing negative 8. I'm just writing 8. Remember, the plus minus takes care of those sign changes. So we need the factors of 8. So that would be a 1 times 8. What else? 2 times 4. And that's it. Now we need the factors of the leading coefficient, so the factors of 2. Only 1 and 2. You'll notice I'm not bothering putting the commas that my brother was putting.
But I was going to reduce as I went along when I was doing this one, but you're not.
No. Let's see if that's enough. You take 1 and you put it over 1, 2. So you put that first 1 over 1, 2. Then you take 2. What do you put it over? 1 and 2 again. Then you take 4. What do you put it over? 1 and 2. Any more? 8. You have to take 8. Put it over 1 and 2. So I didn't need that last one. You took this one, the first factor of 8, put it over 1, 2. Take the 2, put it over 1, 2. 4, put it over 1, 2. 8 over 1, 2. And then we start simplifying. 1 over 1 is 1, so plus or minus 1. 1 over 2 is 1/2. 2 over 1 is what? 2. What about 2 over 2? That's 1. We already have it. 4 over 1. Do we already have it? No, I got to write it down. 4 over 1 is 4. What about 4 divided by 2? What's that? 2. Do we already have it? Yeah, 4 divided by 2 is 2. We already have that listed. 8 over 1. Do we already have it? No. What about 8 divided by 2? 8 divided by 2 is 4. We already have it. Look at that. In this case, 2, 4, 6, 8, 10. Out of the infinitely many numbers that you can plug in for x, these 10 numbers here are the only ones that could possibly make it equal 0. So if we needed to factor this, I'd start off with positive 1, plug it in. Does it give me 0? If so, great, use synthetic division. If not, go on to negative 1. You know what I'd do? I'd be checking the integers first, okay? I'd wait on that 1/2, but just keep on going until you get one that's plugged in.
Now, it doesn't have to be in the same order as we have them listed, but I
think it is. The way I used to go, all the 8 over 1, then all of the 8's over 2. But you've switched it, and I thought that was a good idea, because now the answers fall out in the order in which the program's given.
Let's do one more of them. Let's do 11.
Any questions? Switch back to my work. You're taking every factor of 8, putting it over both of those numbers.
The tricky thing is you've got to make sure you remember you start with the last number. Do that constant term first, because that's what goes on top.
And the multiple choice format for these is nice, except the multiple choice format knows people get them confused, mixed up. And so if you go through and you put the factors of 2 over the factors of 8, one of those wrong answers is the thing that you're going to get. So you've got to be careful.
Oh, you'll notice that there's no view an example on these. I clicked here for no reason. Okay, so I'm not saying that's the answer. But this is the time years ago when the student asked me, "Sweet student, if there's not a view an example, how are we supposed to know how to do them?" And I was like, well, I kind of sort of thought you would do what I'm showing you in class. But she said, oh. But there isn't a view an example of this. I'd love to see it.
Okay. Which number am I going to write the factors for first? Which number do I... 18. 18 is the one I'll do first. The factors of 18. Let's see. 1 times 18. What else? 2 times 9. Are there any other pairs of positive integers that you can multiply together to give you 18? 3 times 6. Oh. Now we need to find the factors of what number? Okay, we don't have to worry about the negative sign, just the number part too. Remember, the plus minuses are going to take into account positive 1 times negative 2 and negative 1 times positive 2. You don't have to worry about that sign there, just the factors of 2. And what are they? 1 and 2. Okay, so here we go. Plus minus.
I'm going to push it up just a little bit.
Yeah, let me push it up a little bit. I'm just going through, writing out the little plus minus fraction bars first. I'll need more in a moment, but this will get us started. We go, take that red 1, and what do we have to put it over? The purple 1 and the purple 2. Then we take the red 2. What's it going to go over? The 1 and 2. The purple 1 and the purple 2. Then the 3, what's it going to go over? 1 and 2 again. Uh-oh, I need some more plus minuses. So, what number am I going to put right here? 6, okay. The 6's will have to go over 1 and 2. Here, 9. The 9's going to have to go over 1 and 2. Here, 18. We have to put it over 1 and 2.
Not hard, a little tedious, but certainly not hard.
1 divided by 1 gives me 1, so I have plus minus 1. And 1 over 2, that's 1/2. 2 over 1, that's just a 2. What about 2 over 2? That's a 1, we already have it, so we don't need to write it again. 3 over 1, we don't already have that, that's a 3. 3 over 2, do we already have it listed? No, so write it down. 6 over 1, okay, there's a 6. 6 over 2, oh, we already have 3. Okay, so we'll mark that out. 9 over 1, do we already have it listed? No. What about 9 over 2? Do we already have it listed? No. 18 over 1, do we already have it listed? No. What about 18 over 2? Do we already have it listed? Yeah, we have it listed. It's a 9, so we can cross that out. So there were 3 repeats that we were able to discard. Out of infinitely many integers, out of infinitely many rational numbers, the only numbers that could possibly make this thing equal 0 are listed right here. 2, 4, 6, 8, 10, 12, 14, 16, 18. Only these 18 possible answers. So, could 7 be plugged in to make it equal 0? Could you use 7 and it equals 0? Is that possible? No, because 7 isn't listed. Is it possible that you could plug in 20? Could you plug in 20 and make that thing equal 0? No. The only numbers that could possibly make it equal 0 are these 18 numbers here. And there's 18 because of the positive and the negative. If you needed to factor that, start off plugging in positive 1. Does that equal 0? If so, great. Use synthetic division. If not, go on to negative 1. Just go through the list until you find one that makes it equal 0.
If it were a 10th degree, let's suppose there's an exponent of 10 in here. As long as 2 is the leading coefficient and 18 is the constant, these are the only numbers that'll work. That's just absolutely amazing to me.
Suppose, let's change this. I'm going to change this. Instead of an x to the 4th, suppose that were an x to the 14th power. These are still the only numbers that could possibly make that equal 0.
Wow.
We're the only ones impressed by this, aren't we?
Well, they're impressed because I'm going to choose the answer. Wait, which one? I clicked this. I didn't mean to. Is it this one?
Mm-hmm.
Well, right when I pulled it up, I just clicked my mouse. So it's this one.
Now, I'm warning you, if you had gotten it reversed,
if you did
2 over 18, one of those responses would be the answer that you get. So you've got to be careful. Always put the factors of the constant term first. Any questions there? Yes. The order in which they're listed does not matter, okay? As long as you have every one of them listed
There were
correctly.
some problems that I always think if the class is really going to make me, if I have a really bad class, I'll assign them, and that's never happened, where it's not multiple choice and you write them out, and they want you to type them in numerical order. If it had told you to type these in numerical order from smallest to large, what would be the first number you type? The smallest
A half.
number? No. Smallest on the number line? Negative 18, Tim.
Oh, you're right. Oh, wow.
Negative 18, and then what? Typing them in from largest to smallest would
Negative
be negative
9.
9.
Negative 6. A negative 9 halves. Oh, wow.
Maybe we should assign one of those one day. Just
Not for my class,
Yeah.
okay? You can just put it for your students, okay?
Yeah. But anyway, so it's multiple choice, those problems. There's no view an example, but view this example, okay? The ones
Which
we've done.
example? The one that I just
Yeah.
wrote out.
I'm going to call it quits and stop the recording now because we're done. Unless there's a question.